buddy. Hold on. Murphy. There you go, pup. Ava. There you go. Okay, so we are into section, I believe it's 5.2, and we're talking about polynomial and power functions. And power functions, hold on. Sorry. All right. Power functions are things like 2x to the fourth, or 2x to the half, or 3x to the 1/4. Even 1x to the 0 is a power function. And remember, this would, if you translated the 1/2 to its other notation, it's going to look like 2 times the square root of x. 1 over x is the reciprocal power function, and that's actually x to the -1. So as long as your exponent is a real number, it's a power function. A polynomial function is basically a couple power functions put together. So you have f of x is equal to x squared plus x plus 1. That's a polynomial. Now, some nice things about polynomials and power functions. They are continuous. Their domains are negative infinity. Whoops. I have to be careful with that. If it's a polynomial function, its domain is negative infinity to infinity. If your lead, okay, so this is getting a little technical here. Hold on, let me change. So if I've got a 3x squared plus 4x, and this is my polynomial. The degree of this term is 2, because the power is 2. The degree of this term is 1. Now, the degree of the polynomial is the degree of the term that has the highest degree. So the degree of the polynomial is the degree of the term that has the highest degree. And that's significant because what we can say about this polynomial is that as we get to infinity and negative infinity, as we push out into the extremes, this polynomial will start to act like 3x squared. And this 4x becomes less and less significant. And so we tend to focus our concern around the origin, but we do need to know about the end behavior. And the end behavior is this is going to act like 3x squared as you're heading off to positive infinity and heading off to negative infinity. So just a real quick note about different powers. So if you have an even power function, like 3x squared, for instance, it's going to start high and it's going to end high. And my drawing's poor. It would go through the origin. If your power function was negative 2x squared, it's going to start low, and then it's going to end low, okay? And that's because of this sign here. If you have an odd power function, it's going to start low and end high if it's like f of x is equal to 2x cubed. And if it's an, put an extra line in there, negative 2x cubed, it's going to start high and then it's going to end low, okay? Now, we have to talk about, very quickly, so we have two things that we're going to look for in a minute. We're going to look for turning points, and we'll look for roots or x-intercepts. So here's our roots or x-intercepts. This is a turning point. And previously we had talked about that relative max and the relative min, and that's really where the turning points tend to occur, okay? I say tend because you can also get what are called points of inflection as well. So you could have a graph that looked like this. And what I'm going to say is this is a cubic. It would be a polynomial. It would be x to the third power plus something x squared, you know, something and so forth. So you get this third power. Well, that third power is indicating your number of spots or number of roots that you could have. You could have up to 3 real roots. You could have 1 real root and 2 complex roots. So if you were to graph a cubic, and you say, hey, wait a second, this only crosses that once. Well, you have 1 real root and you end up with 2 complex roots. And complex roots always come in pairs. We'll try and show you how to get to those in a minute in another video. And how do we get the min and the max? We'll have to talk about that as well. All right. Make sure that you read the section closely. And all right, you have a good day.